Welcome to the third module of the Azure Administrator Certification course. In this session, we're going to review the exam objectives for managing an Azure subscription and resources. In the following 4 lessons, what we're going to do is have a deep dive into managing Azure subscriptions, analyzing resource utilization and consumption, managing resource groups, and managing role-based access controls. As you can see from the subject headings, there's not a lot of new concepts here for us that we haven't already discussed in the AZ-900's exam. However, the lab exercises that we go through are going to push our knowledge to the next level. So once we've done the lessons, we'll do a quick briefing on the lab exercises that we're going to go through in this course, on this module of the course. Then finally, we're going to close out today with a quick recap of the course frequently asked questions. Now, if you've done the previous modules and you've seen the frequently asked questions section, they haven't changed. So if you do already know how to deal with those things, don't feel like you have to sit through that part of the session again. Before we drill into each of the 4 lessons, let's have a look at an overview of the structure of the Managing Azure Subscription Resources objectives and understand the 4 towers of sub-objectives that it contains. As you can see, the third objective for the AZ-103 exam is structured into 4 sub-towers of objectives. In managing Azure subscriptions, we're going to learn about how to make other people administrators of those subscriptions and how to implement cost center quotas and tagging. When we take a look at it, analyzing resource and consumption, what we're going to be doing now is looking at the resources that are deployed, looking at how we monitor them, looking at how we use looking at how much they're used and how much we're spending for those resources. And ideally, what we'll also be doing as well is finding ways to identify when we're spending too much money for a resource and how to go about resizing that resource. Then we're going to take a deep dive look into Azure resource groups. We've already talked about resource groups on several occasions, but in this circumstance, we're going to take a look at the mechanics of how we create a resource group and assign policies to it, and also how we move objects from one resource group to another. Then in the final lesson, we're going to take a look at managing role-based access controls. We're going to look at the custom roles that we can, the sorts of use cases for custom roles that we can create, and the out-of-the-box roles that Azure provides us. We're then going to look at how we assign access using those roles, and how we configure management access using role-based access controls. There's also there's a reading exercise we want you to follow up on troubleshooting role-based access controls, and also as well some information about implementing role-based access controls, how we create an architecture for our organizations of how our people and our teams fit into a role-based access structure schema. In this first lesson of the module, let's take a look at how we manage Azure subscriptions. A Microsoft Azure certified systems administrator needs to be able to demonstrate competency in managing Azure subscriptions. What that means is you need to be able to assign administrators permissions that give them access to do their job. They also need to be able to configure cost center quotas and taggings to help with managing the price and the consumption and spend of resources. Also as well, we need to be able to understand how to assign Azure policies at the subscription level so that they restrict and control what can be done across the entire subscription. When you first create an Azure AD subscription, the account that you use to sign up is granted membership of the subscription level owner's role. As the member of the owner's role at the subscription level, you're able to do anything you like. You can create pretty much whatever resources you like. You can add other administrators and delegate administrative rights to them as well. One of the first tasks you need to consider after you set up your Azure tenant is to identify who the day-to-day systems administrators are going to be. Then what you would do is make sure that there are accounts in Azure Active Directory for those users, and then grant them membership of an administrative role. At the subscription level, there are 4 levels of role that we need to work with. The first one is the contributors role. That's an ideal role where we should be adding people who are going to perform day-to-day administration across the entire Azure tenant. These might be your cloud platform engineering guys, they might be your DevOps teams. The idea is what we're going to do is give those people the ability to do anything they need to within Azure. The easiest way to do that is to grant them membership of the contributors role at the subscription level.
Another subscription level role that exists is the owner's role. That's the role where you're the first account you created, sorry, the account that you signed up for the Azure environment with is being made a member of. The difference between being an owner and a contributor is that as an owner, in addition to getting full administrative access to any of the objects and resources, you're also able to delegate administrative permissions. You're able to create other administrators and add them into the creator's role or the reader's role. The reader role will just grant somebody the ability just to be able to view permissions. So when we get into the labs, we're going to use role-based access controls to create some administrative users and to add them into various role assignments at the subscription level. One of the few downsides of Azure's cloud computing capabilities is that it's very easy for organizations to create more resources than they need or to overspecify those resources and then have them spend more money than they need on consumption. Also, as well, when we have a bill come in from Microsoft, we need to be able to identify which parts of the business might need to pay for certain resources. This is where we can implement cost center quotas and tagging. So, a cost center quota is where we apply a tag object to a resource or a resource group that identifies which part of the business is responsible for paying for that resource. We can also implement quotas within Azure that can restrict either how many resources or what level of cost of consumption a particular cost center or a resource group can consume. In the labs, we're going to set that up. We're going to set up a couple of resource groups. We're going to apply some cost center tags to identify which resources belong to certain parts of the organization. And then we're going to implement a quota that would effectively restrict how many instances of particular types of resources can be created against that cost center. The concept of resource tagging is very simple and very powerful. Resource tags work on a key value pair arrangement. So we have a key that identifies what's the label we're applying here, and a value which says what is the value that's attributed to that. If we create a cost center key and we apply the tag value of marketing to that, we're basically inferring that this resource is funded by the marketing department. We can use tags for many other purposes, and we'll do a bit more of a deep dive into them later in this module. In addition to role-based access controls, Azure also gives us another mechanism to restrict what people can and can't do and enforce them to follow our organization's good practice. That's called Azure policies. What we can do with an Azure policy is determine a set of rules that controls what people can and can't do in the Azure environment. Azure policies are all about controlling what resources can be deployed, how those resources have to be configured, and restricting what administrators can do. It's important to bear in mind that certain policies need to be applied at the subscription level. So, for example, if we apply a policy at the subscription level, that will take effect on all the resources and all the resource groups that are within that subscription. So the kind of policies you're going to apply at the subscription level are the ones that need to apply consistently throughout the entire organization. Now, it is possible to configure exceptions to policies. So we could still assign a policy at the subscription level and say, let's maybe make the subscription owners group, create an exception that excludes the owners group from having that policy attached to it. The whole idea here is that any sort of policies we apply at the subscription level will apply to pretty much everything in our environment. During the labs, we're going to create a couple of simple policies that will restrict what administrators can do. We're going to implement two policies in particular. The first one will whitelist certain sizes of virtual machines that can be deployed. The second one will whitelist the Azure regions where virtual machines can be deployed. We're going to apply those restrictions at the subscription level using an Azure policy. And what you'll see then when you come along and try and create a resource that doesn't follow that policy, we won't be able to implement it. Later on in the course, we'll take a look at how we implement policies at the resource group level, which is quite important because some policies we may need them to be applied more granularly. So if we take one particular resource group where we've delegated administrative access to, say, a project team of engineers and developers, Maybe we just need those policies to be applied at one particular level. So it's important to remember that Azure policies can be applied at the subscription level, at the resource group level. They can even be applied at the management group level as well. What we need to do is to determine where we should be assigning the policy for optimal use, and that's about the scope of what needs to be controlled. In Lesson 2, we're going to take a look at analyzing resource consumption and utilization. To be able to pass the AZ-103 exam, we need to demonstrate strong competencies around the following areas. We need to be able to use diagnostic settings on resources to identify how we log and monitor them. We need to be able to create a baseline for a resource that identifies what normal behavior for it looks like, so that the Azure Monitor can identify characteristics and behaviors that are out of character. We need to be able to work with Azure Azure alerts. That means being able to create an alert based on a role and being able to interact with an alert. So when one is generated for us, we can take some action on it and rest it, which means to dismiss it. We need to be able to analyze alerts from multiple subscriptions, and the way we do that is using the log file analytics capability of Azure Monitor in conjunction with Event Hub to forward alerts from one subscription to another. We need to be able to analyze metrics across subscriptions as well. Now we're able to see the alerts that come across from one part of the organization to another. We now also need to be able to look at the performance of resources across multiple subscriptions. We need to be able to create action groups that will take remedial action for us in the event of an alert coming up. We need to be able to monitor for unused resources, which is quite essential. Quite often when people delete objects like virtual machines, they'll forget about some of the constituent components of that solution. So for example, your subscription may have several unused virtual hard drives that are just sat there consuming storage. We need to be able to use Azure Cost Manager to monitor a spend and to report on spend. We also need to be able to get to use the log search query in Log Analytics to be able to search through our queries. And then finally, we need to be able to view alerts in Log Analytics and search against them. So there's a huge amount of telemetry being generated by Azure Monitor and by Azure Diagnostics. The clever part is being able to cut through the background noise and see the information and alerts that's relevant to us. One of the challenges with cloud computing is that because we've created a self-service type portal where our developers and engineers can come in and create whatever resources they want very quickly, the risk is that they'll spend too much money on resources that aren't necessarily needed. Ultimately, anything we create in Azure needs to be funded. So overall, the IT department will have been given a budget for their spend. For many organizations, that was traditionally a bit of a challenge. They were basically trusting quite junior resources with access to the Azure portal. People would go away and provision things that they didn't need, they'd maybe oversize things, and ultimately money was spent unnecessarily. Back in 2018, Microsoft acquired a company called Cloud9. Cloud9 had created a very, very powerful set of analytics tools that worked not only with Azure, but also with AWS and Google Cloud. What Cloud9 would do was communicate with your Azure subscription through the application programming interfaces to it and identify what resources you had provisioned. It would also work with performance metrics from the platform as well to identify what you'd bought, how large it was, and how well it was being consumed and what the performance looked like. It then used some AI algorithms to identify how resources could be resized to reduce spend. So, back in 2018, Microsoft purchased Cloud9. The first thing they did was they integrated most of the Cloud9 functionality into everybody's Azure portal. And that was what was released as Azure Cost Manager. In the labs, you're going to go and set up and configure Azure Cost Manager to look at spend in your environment. You're going to be able to see some reports in there that give you advice on how to resize your environment. You can also use Cost Manager to implement quotas and policies. So we can delegate a particular part of our overall budget to an individual resource group. That means we can set in place quotas and limits as well to control how much spending is done within granular areas of our subscription. Whenever a resource is created in Azure, there's an associated set of diagnostics taken for that resource. Diagnostics fall into two categories. The first one is performance metrics. So metrics say things like how many times the machine has been started, how many users have logged onto it, how fast it's performing, how much CPU usage is it consuming. And we also have log events as well. Audit log events log administrative changes to a resource. So for example, if somebody comes along and restarts a virtual machine through the management portal, we'll get a log event for that. So what we need to be able to do for resources is to be able to go in and individually configure diagnostic settings. Now, it's possible to implement diagnostic settings on a resource by resource level. So we can choose to enable or turn off diagnostic settings for an individual resource. We can determine how long resources are retained for in the logs. The default is 7 days, but we can increase that value up to 90 days at no extra cost. And if we want to store log information beyond that, we can simply pay for the additional storage overhead. So, one of the things you're going to be doing in the labs is going into the diagnostic settings of a resource and setting it up to maintain logs and to retain them for a longer period of time. What we're effectively doing there is telling Azure to capture the logging and diagnostic information for the resource that we've created and keep it in a storage account. Later on, we'll use Azure Monitor to be able to take and collect that information and put it into a log file analytics workspace where we can have a holistic across the board view of all our diagnostic information and be able to apply powerful reporting to that to cut to the stuff that's relevant to us. Diagnostics generate events. An example of an event would be a virtual machine has been created. Another example of an event might be a virtual machine has been deleted. So what we need to be able to do, obviously you imagine there's a huge amount of event information being kept and stored. What we need to be able to do is focus on the ones that provide value to us. So if we take, for example, an event that tells us that a virtual machine unexpectedly restarted, that's something that an administrator or the operations team should take notice of and perform some kind of action against that. So what we do for events is we create alert rules. What a rule is it's a set of conditions that if those conditions are true, an alert will be generated. So there's two parts to that. The rule component says, what are the conditions we're looking for? What are the type of log events that indicate this kind of thing is happening? Then we have the notification part, which says, what do we do about it? So that notification part can be sending an email to a group of users or to a distribution list, or it can be running something called an action group. And an action group will take an automated response to something and try and undertake self-heal. Most of the time, though, with alerts, what we're doing is capturing them and looking at them and taking some sort of manual interaction. So during the labs, we're going to create several monitoring rules that will generate alerts for us based on certain criteria. For example, a machine running out of hard drive space or CPU usage having been stuck at a very high percentage for a long period of time. Then what we're going to do in those labs as well, once we've created some alerts, we're going to go in and interact with the alerts, acknowledge them, close them off, and view some of the supporting information that Azure provides behind them. Many organizations have found themselves in a position where they're having to maintain multiple Azure subscriptions. They also find themselves in a situation where they're having to work with multiple Azure AD tenants. One of the most common circumstances where that can happen is we have a company who's a service provider. Take, for example, here at DXC, we might look after multiple customers' environments. And maybe what we want is a centralized monitoring log file analytics workspace where we'll get any activity logs from any of the subscriptions and tenants we run moved into one manager of managers workspace. So the way we implement that is to basically implement an event hub. We create the event hub in the subscription where we want to get the log information from. That event hub then gets configured to receive any of the logs that are generated. The event hub then basically takes and forwards those events across to a logic app that we create in the service provider subscription. So that would be the subscription where we want to have our manager of managers tool, where we're going to centrally collect all those logs at. What the logic app does is look at the logs, that are coming through that are being provided to it via the Event Hub, and then it'll write them into the Log Analytics workspace. Once we have those logs there centrally in the Log Analytics workspace, we can put in place whatever queries, rules, and alerts we want centrally to let somebody know when something's happening in the environment. This is a really good and simple way of providing cross-subscription and cross-Azure AD tenant monitoring. So, there are a couple of steps we need to follow through, and we'll do this in the labs. The first part of the process is to create an event hub in the customer subscription. Then what we're going to do is we're going to configure the event hub. We're going to configure the logs to export all the activities into the event hub. Then over in the service provider subscription, we're going to create a logic app, which is going to take and parse those events and write them into our log analytics workspace. Then we're going to test and troubleshoot the logic app just to make sure it's performing the way we want it to do. Finally, in the last stage of that lab, what we're going to do is view Azure activity in the log analytics space and see events and alerts coming up from different subscriptions. Azure alerts can trigger one of several things from happening. One thing an alert can do is to trigger a notification being sent to somebody by email. If we want to do something a bit more complex though, we can create an action group. So what we do with an action group is basically determine, we provide a name for the group to identify itself. We can also give it a short name, which we can leverage to very quickly reference it from automation. We need to assign the action group to a subscription that pays for it, and we also need to add it to a resource group, just like any other kind of resource in Azure. What our actions group can contain, though, is a series of multiple actions that will be taken if a particular rule triggers an event. So, the sort of things we can put in there, we can create a notification on there that can send an advanced notification, such as an email or an SMS message to a particular group of administrators to let them know that something's happening. We could create a webhook step in there that would be used to send a HTTP command from Azure Monitor into a third-party management tool like ServiceNow or System Center Service Manager to create an incident in a service management tool set or to trigger something else from happening. We can also trigger an automation runbook happening, which would have Azure send a runbook of a sequence of diagnostic and self-heal events to the affected resource. So, action groups are a great way of bundling together multiple responses to alerts. So we can either integrate with service management, attempt self-heal, and also to make sure that administrators know what's going on. Azure gives us two mechanisms to monitor the spend and usage in our environment. Obviously, when we consume any resources, the diagnostic logs in Azure do keep a track of the spend and consumption. So it's easy to work out from those logs how much we're paying for a particular resource over a particular period of time. So we can use Azure Monitor to drill into usage and estimated costs to have a look and see what particular resources are costing us. We can also use Cost Manager, or formerly the Cloud9 components, to provide a monitoring set of alerts that will let us know if spending goes above a particular amount. We can also use an action group to say what happens once a particular resource group exceeds its budget. So perhaps we set up a rule that's an action group that says when it gets to 80% of its budget, send a notification to these people. When it gets to 95% of its budget, scale down the virtual machines. When it hits 100% of its budget, shut down the virtual machines. The whole idea there is that we can not only keep on top of tracking costs, but we can also use action groups as a way of controlling costs and enforcing budgets. Obviously, it's necessary to work with financial stakeholders when it comes to Azure. Because the costs of our environment aren't fixed, we may need to go back and justify why particular costs have occurred, or to identify which particular parts of our Azure subscription are spending more or less money than planned. So, not only does Azure Cost Management provide a whole bunch of cost analytic reports out of the box that we can take to drill down into which resources are spending the most money, which resource groups are spending more than their budget. We can use the cost management reports to drill down and to understand where the particular items of cost are happening. In the first lesson today, we discussed applying cost center resource tags to resource groups and resources. We can also use that information we've used there by tagging resources and resource groups. We're effectively associating them with a cost center that will ultimately be paying its bill. We can use cost management to identify which cost centers have incurred cost. We can also provide a report that tells them, this month you've spent this much money, this is what you've spent your money on. You've spent it on these 5 virtual machines, this virtual network. We can also use cost management to provide advisory notes as well. So advisory recommendations will say things like, you've spent £5,000 on virtual machines, you have 4 of them, and their provision is A8 virtual machines. If you resize them to be B2 machines, you'll spend a lot less money and it'll still accommodate your workload amounts. So in the labs, you're going to configure Azure cost management. You're going to implement some quotas, and you're going to implement some resource tagging, and we're going to also implement some recommendations based on good practice findings. When we configured Azure Diagnostics, we were telling Azure to make a log of any performance information and to make a log of any audit information as well. All that information gets held in a storage account. Now, whilst the actual overhead for that storage is not that big, log files tend not to be very large objects. They're not very big in terms of storage capacity. However, because we might be dealing with hundreds of log entries being created per day, the difficult bit for us as human beings is to identify the logged events that are relevant to us or to a particular incident or project we're dealing with. So, one of the benefits of log file analytics in Azure is we bring all of those logs together into one monitored storage space, and we've got a really powerful search engine that we can use to search on the contents of those logs to find patterns. So for example, one of the things we can do using a log query is to say, show me all the logs for this particular resource in the 1 hour period leading up to this service outage. To be able to work with this stuff, there's 2 ways we can do this. We can use some of the out-of-the-box safe queries that will respond really well to kind of incident management and capacity management type challenges. We can also create our own custom queries. Now, the language that we use in log analytics is very similar to Transact SQL. Don't worry, in the exam, you don't need to be able to write one of these queries. What you need to be able to understand for the exam, though, is that it's possible to query logs and to kind of understand what types of queries you might write to gather particular information. Most of the time, what the exam will test your ability to differentiate is whether you're searching against metric data, i.e. performance information, or audit data. In the labs, we're going to configure log diagnostics. We're also going to go and do a couple of exercises where we use log analytics to go away and query a diagnostic storage account to find out particular events that might lead up to a particular instance of or an incident happening in our environment. The whole purpose of alerts in Azure Monitor is just to focus us on what's happening now that's of real relevance to us. With alerts, we've created a rule that will generate an alert in response to a set of criteria happening in the logs. So, in log analytics, we get a centralized view of our alerts. One of the things we're going to do in the labs is go into the log analytics workspace and browse various alerts. What we can do in there is we can look in the properties of the alert and see what's happening, find and understand why the alert's been generated, and then we can take appropriate reaction from there. We're also going to create a couple of management action groups as well. And what the action groups do is determine what happens in response to an alert happening. Now, there's a couple of scenarios we're going to implement there. The first one is doing some advanced notifications, where maybe we want to send somebody a text message rather than just an email message if it's out of hours. We'll also be triggering some things to happen like resource controls. For example, we'll configure an automation runbook that will automatically restart a virtual machine. In this third module of the lesson, we're going to take a look at managing resource groups and how we can use resource groups to structure the resources and objects that we have in Azure. Resource groups are the cornerstone of organization within Azure subscription. So it's no great surprise that as a Microsoft certified Azure administrator, you're going to need to be competent in being able to use resource groups to do several things. For the exam, you need to be able to understand how to create an Azure policy and to assign it to a resource group so that that policy only takes effect to the objects within that resource group. We need to be also able to configure resource locks to prevent accidental deletion and accidental administrative changes. We need to be able to configure resource policies. We need to be able to identify auditing requirements. We also need to be able to implement tagging on a resource group as well to identify the object and allow us to support automation. And finally, we need to be able to understand how to move resources from one resource group to another. And finally, how to delete a resource group and the impact that can have on the resources in it. To quickly recap on what we learned about resource groups in the AZ-900 course. Azure resource groups are effectively a logical collection of Azure resources. So for example, a virtual machine is a resource. It would make sense to keep the virtual machine in the same resource group as its virtual hard drives, its virtual network card, and any storage accounts that are used by it as well. The idea around a resource group is that we're creating an administrative grouping of objects that should be managed and kept together. So the purpose of resource groups is several-fold. One is to make sure we consistently configure everything within that resource group. Another use case for resource groups as well is delegating administrative control to that group of resources to a group of engineers. So for example, we might create a resource group that contains all the components for a line of business application. We might then use the role-based access controls that are created automatically for that resource group to grant owner or contributor rights to the engineers that need to work with just that line of business application. So, as the owner of just that resource group, they would be able to see the resources that are in that resource group and be able to administer and change them, but they wouldn't be able to affect anything outside of that resource group. Azure policies are a mechanism in Azure we use to implement governance controls. So for example, I might create an Azure policy that says I can only deploy resources in the UK North and UK South data centers. What had happened then, if I assign that policy at the subscription level, nobody would be able to create any resources outside of the UK geographical region. I might create another policy that says we only allow type A virtual machines to be created, other ones are too expensive. So if we applied that policy at the subscription level, nobody in the subscription would be able to create any overly expensive virtual machines. Under certain circumstances, when we create Azure policies, we may want that policy to only affect a subset of the organization. So maybe when we create these policies, we only assign them to individual resource groups. So for example, if I created a resource group called United Kingdom Virtual Machines, I could apply a policy at that resource group that says we can only create virtual machines in that resource group. And we could create another policy against and assign that to the resource group that says we can only deploy objects in the UK North and UK South data center. So by applying those two very simple policies that are available out of the box in Azure to one resource group, and by delegating administrative access to certain engineers to only being able to work with that resource group, we've prevented people from being able to deploy the wrong type of resource and to deploy resources in the wrong location. Azure policies come in two formats. One is out-of-the-box policies, where we can just take and apply them and assign some values to them. If we want to configure something a bit more powerful or a bit more specific to our needs, we can create a custom policy that we build ourselves and assign that to a resource group or to our entire subscription. An individual policy implements one rule. If we want to implement a suite of policies and rules together, what we can do is we can create an Azure initiative. An initiative will contain multiple policies grouped together. We can use initiatives to assign policies much more effectively. If we create a standardized initiative that says we can only deploy machines in certain regions, we can only deploy machines of certain types, we can't deploy Linux virtual machines, for example, and if those are our standing rules for for creating virtual machines across our organization, we could apply that initiative at the subscription level, or we could apply that initiative at an individual resource group level or at a management group level as well. In the labs, we're going to create a couple of Azure policies. We're also going to create an Azure initiative that binds together several policies, and we're going to attempt to deploy those to an individual resource group. By doing that, what we'll see is that resources that aren't inside that resource group aren't affected by those policies. The resources that are in there and the users that have rights in there and try to create objects in that resource group will be bound by all of the policies that are put in place from that initiative. An Azure resource lock prevents unintended or accidental deletion or modification of a resource. Let's suppose I have a resource that's a virtual machine. Let's suppose it runs a domain controller role. What I can do is I can write a PowerShell script to look in my Azure environment and delete every virtual machine. So maybe I don't want to delete every virtual machine. Maybe I just want to delete ones in my development environment, but I accidentally send the right script to the wrong resource group. And instead of deleting pre-production virtual machines that need to be deleted, I accidentally delete a production virtual machine. If I do that, and I also delete the virtual hard drives that are underneath that, I've taken away that virtual machine if I've deleted it. If I delete something like a storage account, or a site recovery vault, or a backup vault, or a storage account, I'm deleting all of that data. The moment I delete a resource in Azure, the ones and zeros on the hard drives in Azure are all set back to zero. Microsoft has to do that because they make a commitment to us to not retain our data and to securely dispose of it once we tell them we're finished with an object. The way we tell them we're finished with an object is to delete it. So it's very important that we put in place resource locks to prevent accidental deletion of an object. It's very easy to do that. You go into the portal, you go into the resource you want to control, you go to the locks tab and you add a lock. You've got a choice of creating one of two lock types. We have a read-only lock, which means unless that lock is removed, nobody can change any of the parameters in the Azure management plane for that resource. So by applying a read-only lock, I can prevent somebody from resizing a virtual machine, stopping or starting a virtual machine, and so forth, unless they intentionally remove that resource lock. Now, it sounds like a very simple thing. It's very easy to remove a resource lock, but it does make you actually think about what you're wanting to do. So if I don't remove the resource lock on the virtual machines I don't want to have deleted or modified, any kind of script or automation or portal action I perform on those resources will not happen. The other type of resource lock we have is a delete one, and that prevents deletion of the resource. If I just apply a delete resource lock, an administrator could come along and change my virtual machine. They could change the virtual network if they wanted, as long as they have rights to do that. What they can't do, though, is actually delete it. The whole idea around resource locks is basically it's a way of telling administrators to say, are you sure you want to allow this object to be deleted or to be modified? So in a structured environment, the best way to approach this is to have read-only and delete locks applied to everything. And it's only when you're choosing to do some sort of planned administration that somebody would come along and remove those resource locks. So for example, we can use this as part of a privileged access management strategy. In a subscription, every storage object will be set to delete. So we're set with a no delete resource lock. Only when somebody submits a change request to say I want to delete a storage account, would somebody come along and remove that delete lock temporarily whilst that object is being deleted. We can also use Azure policies to monitor which resources have resource locks in place. That's quite good because we want to make sure that resource locks are in place, and we need to have a way of monitoring that they are in place as well. It's also possible for us to apply policies at resource groups and to individual component resources. The idea being that we can apply those locks to an entire group and we can apply them consistently. Quite often when we work within regulated industries or organizations that have a set of security governance rules in place, it's important that we configure Azure to implement auditing the way an organization mandates it should be implemented. So some of the conditions that are put in place by auditing requirements are we need to make sure that audit logs are retained for a particular period of time. We need to make sure that audit logs can be shipped off someplace else and independently analyzed by approved administrators. So quite often, not only does the auditing requirements affect the diagnostic settings we put in place on a resource, it'll also handle how we handle the audit data as well. So for example, if we have a requirement to keep that information in a separate place, that would be a use case for using a log file analytics or an operations management suite repository to centrally store all that data in. Now it is possible to deploy that in a different tenant and to use an event hub and a logic app to forward that information to another tenant. So we could have an entirely isolated environment just for auditors to be able to access logs. As we discussed in the Azure Fundamentals course, resource tags are about applying information and associating that information with a given resource. So for example, if I create a virtual machine, I might want to know certain information about that virtual machine other than its technical configuration. So for example, I might want to know which company uses that virtual machine. So I would create a resource tag called company and assign it the value of, say, Wingtip Toys Corporation. Maybe I want to be able to find out who the technical or the business owner is of a particular resource so that I can communicate with them if I need to do a change to something. So what I can do is create technical owner and a business owner tag and assign values that maybe have their email address in. Being able to identify the cost center for a resource through a resource tag is quite a powerful thing to do because that allows us to take the bill that we get in from Azure, put it into Azure Cost Management, and to allocate chargeback to individual organizations based on which resources are owned by a particular or sponsored by a particular cost center. Some other examples of resource tags that I would typically implement for my customers include the associated service level agreement. So if I've got an SLA of 99.9%, I know I have to be very careful when I modify resources. Maybe I also put the maintenance window in as a resource tag so I can look at it and say, this machine has a service outage window every Thursday night between 10 p.m. and midnight. So I can use that in my automation as well. I'm a big fan of putting a review date against each resource group in Azure. And all that review date is, it's literally 6 months from the time when the resource was created. What I then do is run a report in Azure Log File Analytics that says, give me a list of all resources or create an alert for any resources whose review date is equal to today's date. That way I'll get a nice little list emailed across to me of resource groups that have been created, that it's been 6 months since they've been created, and I should be going back to the business and the technical owner to discuss whether or not it's still needed, whether or not it's still correctly sized or not, or if there's anything we can do to modernize it or to reduce its cost. Then finally, one of the other resource tags I'll apply is an environment tag that just determines whether a resource is part of a production, pre-production, test, staging, or development environment. Resource tags are really powerful. When we search for a resource, we can filter by a resource tag. We can apply anything from automation scripts to firewall rules based on the values of resource tags that are assigned. One of the ways to get resource tagging done correctly, though, is there's an Azure policy we can implement that forces the resources that are a member of a resource grab to inherit the resources from the resource group. So that means we can centrally apply tags to our resource groups and have the component objects receive or inherit the tag values from that resource group. That's a really powerful way of ensuring we're consistently documenting our environment through resource tags. It's also possible to implement an Azure policy that mandates certain resource tags are applied to our objects at the time that they're created. So we can basically force administrators to be able to answer each of the questions to make sure that the proper resource tag values are assigned to a resource when it's created. Even with the best planning in mind, it's always possible to get your resource group structure wrong or to need to make changes to our resource group structure. One of the things Azure made possible a couple of years ago is the ability to move component resources from one resource group to another. Now, there are certain types of some rules that we need to follow to make sure we're compliant to allow Azure to be able to correctly move those resources. So, if we're trying to move an Azure app service, if we're trying to move an Azure DevOps subscription, if we're trying to remove a recovery services vault, virtual machines, or virtual networks, there are specific sets of requirements for how we move those particular objects. The most significant ones for this course are the virtual machine ones. So for example, if we're moving a virtual machine from one resource group to another, it's important that we make sure its underpinning objects like its IP address, its virtual network adapters, and its virtual hard drives stay in the same resource group as it. It's fine to move them from one resource group to another, but we need to make sure those resources stay together. The source and destination subscriptions must be active. What that means is what we can't do is take some resources and move it to a resource group in a subscription that's no longer active, so it's got no way of paying for things. To move a resource from one resource group to another, all we do is open up the resource group in question, highlight the component objects we want to move to a different resource group, and then click the Move to Another Resource Group button from the Move button at the top of the screen. One of the things you'll see in there as well, it's also possible to move resources from one subscription to another. That means effectively changing who will pay the bill for those resources. One of the powerful things about creating a resource group is that we're creating a logical grouping of resources that should belong together. It should be part of the same management lifecycle. So if I've created 5 virtual machines for a test environment, and I've also created virtual hard drives, virtual network cards that go along with those virtual machines, and I've stored them in the same resource group, I can just delete one resource group to get rid of all those objects and deprovision them. So it's entirely possible for me to come along and delete an entire resource group. What will happen then is Azure will ask me to confirm if I want to do that delete operation, and it'll make me do that through the portal by typing in the name of the resource group accurately and correctly. There are a couple of considerations to bear in mind when deleting resources from a resource group. For example, if we're trying to delete resources that have an underpinning object associated with them, that delete job may fail, and we might find that the resource group itself isn't deleted and one or two component objects are left. If that happens, what you need to do is look at those objects and see what they are underpinning elsewhere. So for example, if I've accidentally moved a virtual network card from one resource group to another, and I try to delete the resource group where the virtual network card lives, but that virtual network card is still attached to a virtual machine, I won't be able to delete the virtual network card until the virtual machine has been deleted. So some deletion activities do have prerequisites. During the labs, we're going to go in and we're going to take a look at moving resources from one resource group to another, and to create a resource group with lots of objects in it, and just to delete them by deleting the resource group. In this final lesson of the module, we're going to take a look at role-based access controls and how we can use them to delegate and enforce administrative permissions in Azure. In the AZ-103 exam, you can expect to see many questions coming up about role-based access controls. Typically, about 20% of the exam questions are based on managing role-based access with RBAC. So, we need to be able to understand how to create a custom role in Azure. We need to understand the out-of-the-box roles that are created for us automatically, and when and why we would need to create a custom role. We need to be able to configure access to Azure resources by assigning the user accounts of administrators into roles that give them rights to access those resources. Also, as well, it's important that we're able to troubleshoot role-based access controls and to be able to plan a role-based access architecture. Azure provides 5 types of roles. At the subscription level, we have the owner role. The owner role, the owner of the subscription, is able to create whatever resources he likes, perform whatever kind of administrative changes, deletes, modifications that he or she wants to do on any of the objects or resource groups or resources in the subscription. The owner can also make other people contributors. The contributor role, just like the owner, can create whatever resources or resource groups he or she wishes in the subscription. However, what they can't do is make other people contributors. Only an administrator can grant other people administrative access. At the subscription level, we also have the reader role. So if I want to be able to give somebody the ability to come into the Azure portal and look at the configuration that's there, but not be able to change anything at all, I can make them a member of that reader role at the subscription level. Because we're granting membership of those roles at the subscription layer, the people that are in those roles are able to have that level of access across everything in the subscription. It's also possible, so Azure also provides roles at the resource group level. What that means is when I create a resource group, there's automatically an owner, contributor, and reader role created that's assigned to that resource group. And if I was to add somebody into the owner role for that resource group, they would have owner privileges just for the contents of that resource group. And it would be the same if I added them to the contributor or the reader role. They would just be able to contribute to its configuration or read the configuration of what's in that resource group. It's also possible to implement roles directly on individual component resources. It's just a little bit inefficient to configure that. So normally, if you do need to configure any specific resources in any great number, you'll use an ARM template or an automation runbook to apply those permissions consistently to individual resources. However, most of the time as an Azure administrator, you'll be adding people to roles either at the subscription level or the roles at the resource group level. In the Azure Management Portal, there is a blade on every resource object and resource group created called Access Controls and Identity Management. We use that blade to configure to check the access. By checking the access, what I can do is provide the name of a particular user or group of users and see what level of access they are granted to that resource or to the resource group. We can use that as a great way of troubleshooting when people don't have the right level of access they expect to have. The Role Assignments tab in that page will allow us to grant people membership of a particular role. Then we have the Deny assignments. What we can do is basically deny anybody particular rights to a resource or a resource subscription. So let's suppose I'm the owner of the subscription and the business wants to prevent me from being able to delete virtual machines in a particular resource group. What I could do, I could still have owner, I could still be a member of the owner role at the subscription level, but on a component management group, maybe I've been denied rights. Maybe I'm denied all control in there. So what that would mean is I can do anything I like elsewhere in the subscription, but I can't do anything in that targeted resource group. Also as well at the end, we can see the out-of-the-box roles that exist for that resource and any custom roles that have been created as well. Azure provides quite a large number of built-in roles. So we've already discussed the owner, contributor, and reader roles. There are also a bunch of administrative function-related roles that exist as well. So I can have a role that allows somebody the ability to configure the backup jobs, undertake a restore job, configure monitoring, look at the alerts for a particular resource or resource group as well. So there's a huge number of out-of-the-box roles called built-in roles. The trick is if we do come across a use case scenario where we need to assign a very, very granular set of privileges and there isn't an out-of-the-box role available for it, we may need to create a custom role to give that granular level of access. Creating a custom role does require a little bit of scripting experience. Custom roles are held in JSON files. You can see here from this example JSON file we have here that the JSON file identifies the name of the role that's being created. It also has a unique identifier number applied to it as well. There's a parameter called isCustom, and that should be set to true as if that's something we've created ourselves. If we set that isCustom rule to false, it won't show up in the portal. We need to also define a description. So for example, in this case, our description reads, can monitor and restart virtual machines. Then under the action section of the JSON script, what we're doing is identifying the types of resource that this role has access to. So for example, here where we've said Microsoft.storage, that means what we're going to do is going to give this person some ability to manipulate Azure's Microsoft storage objects. So within Microsoft storage, there's a wildcard. That means this level of permission is going to be granted to all storage related objects. And then finally, after the last slash, there's a read value. So what we've done there with that one rule is to say members of this group can do anything they like to storage objects. So they can read any storage object they like. If I change that last value from reader to owner, they would be able to do anything they wanted to storage objects. So you can see here by using these action definitions, we can determine what level of access people can have to entire types of resources. We can also as well, if we look a bit further down, we can see here we've got under the Microsoft Compute schema, what we're doing is we're specifically allowing members of this role to be able to work with the virtual machine startup action. And what that action right means is that this role can trigger that action from happening. So here what we've done in this role is we've basically implemented some logic that says people who are a member of this role can start or restart virtual machines. Again, we need to be careful when we use those wildcards because obviously the wildcard means any object of that type. We can also use a role to explicitly deny certain actions. So there's a section in the report called not actions. So any actions I choose to add in there, this role will explicitly be denied them. When we've created a custom role, it will appear to be slightly different in the Identity and Access Management console. Anything we create as a custom role, the icon for a role looks like a little green person with a box, a little cube next to them. Out of the box roles are identified with a blue box. Custom roles are identified with an orange box. So it's important that you're able to identify them in the console. Troubleshooting role-based access controls can be as complex or as simple as the role-based access schema you've chosen to implement for your organization. So, there are various sets of guidance available from Microsoft that we need to be aware of. There's a document up on the Azure documentation which is all about role-based access control troubleshooting. If you follow the link at the bottom of this page, it'll take you through each of the main scenarios. So for example, there are some limitations and there are some known issues with role-based access controls in Azure that we should be aware of. Now there's no point in parrot fashion remembering all of these roles, but what I strongly recommend you do in preparation for the exam is go and visit this document and read through it. That will help you get an idea of the overall process that you go through when trying to troubleshoot a role-based access control. Now it's time to try and identify how we would implement a schema of role-based access controls for our organization. As you can see, we've got the choice of creating roles at the subscription level, at the resource group level, or on individual resources. Then within our organization, we have teams within our company that need to do particular operations. So for example, we have service delivery managers who need to be able to look and report on things and look at configurations. We've got security operators who need to be able to choose who can and can't administer particular resources. We've got the DevOps team who need to be able to monitor, backup, and provision resources. We've got the cloud platform engineers who need to be able to maintain the entire Azure subscription. And we've got project-related software developers and systems engineers who need to be able to build out solutions within their part of the environment. And also as well, we occasionally have external consultants visiting who will come along and look at our entire Azure environment or particular parts of that environment to identify whether it's correctly configured or not. So to implement that role-based access control schema, the simplest way to do that is to create group objects in Azure AD and add the members of each team into the relevant team-based group. We then nest those groups into the relevant role within Azure. That way, if somebody changes jobs, let's suppose somebody gets promoted from the DevOps function into the Cloud Platform Engineering function, by changing the group that user is a member of from being DevOps to Cloud Platform Engineers, they will then inherit the correct role memberships to give them the level of access they need to do their job. So let's look at how we've chosen to break down this structure. The Cloud Platform Engineers, who need to be able to do everything to the environment, we're making them a member of the owner role. What we're also doing as well is the DevOps and security operators, we're making them a member of the contributor role for the entire subscription. That way they can go on and perform the engineering they work on any resource that's in there. Project systems engineers and project software developers, we're going to also make them a member of the contributor role, but only for the resource groups in which they are allowed to have access. So we're giving them contributor rights, but only to particular resource groups. For the service delivery managers, we've chosen to give them reader rights against the entire subscription. That way they can come along and run reports and look at the configuration of things, but not make any changes. And then finally, for the external consultants that need to come in and evaluate the environment, we can make them a member of the reader role, either at the subscription level, if they're doing a across the subscription review, or if they're just looking at the health and configuration of an individual solution, we'll just give them access to an individual resource group as a reader. That means they can come along and look at things and evaluate things, but not make any changes. Then finally, in this particular scope, we've not chosen to implement any resource-specific controls using role-based access controls. We're implementing all our controls by targeting them at either the subscription or the role-based access group. It's only by very, very extreme circumstances you would ever really want to lock down grant people access to individual resources, because that becomes very difficult to administer at scale. That brings us to the end of the theory modules we need to learn for managing subscriptions and resources. One of the good things about this module is there's not as much theory to cover. However, we do need to go through several hands-on exercises to make sure we understand the nuances of configuring resource and subscription management. During Lab 3, there are several exercises we're going to go through. The first one, we're going to assign administrative access. We're then going to create some resource groups and use them to delegate administrative controls. We're going to implement and configure Azure Cost Manager and use that to create some reports around spending and consumption. We're then going to configure Azure Monitor and use that to centrally log all of our performance and audit data into one place and to provide alerts based on that. Then we're going to manage access to resources using role-based access controls applied to resource groups and the subscription level. We're also going to create some simple Azure policies that have got quite powerful effects in terms of locking down what people can and can't create. We're then going to group several of those policies together as initiatives and assign those policies to resource groups and subscriptions and view the effects they have. For the managing subscriptions and resource set of objectives, it's vital that you get very strong hands-on experience with this. It's quite a light subject in terms of conceptuals and theory, but the hands-on experience is very vital. So do make sure you get the lab briefing and you follow through each of these activities. So that brings us to the end of this module. As you can see, we've finished the theory content faster than we normally would for one of these modules. That's because the Azure Subscription and Resource Management is very much a hands-on module. So your next step is to get in there and do those labs as per the deployment guide. Right, our next module is going to cover off Azure Virtual Networks. That module itself will probably run up to the full 2 hours to do all the theory, but the labs will take a little bit less time than this week's labs have taken. Thanks very much for attending the course this week. Good luck with the exams, and I'll speak to you on the next session.